Yeah, hi folks, it's Michael again, and I finished building this encoder demonstration here, and I did some tinkering, some measurements, as you can see here, and some considerations on paper. Well, that's the PCB we built yesterday, and well, let's show you what it does. This is the encoder. I installed a little knob, so it's a little more comfortable to handle. Yeah, you see, I'm turning it right, and then the display is counting up from 0 to F. So the hexadecimal numbers 1, 2, 3, 4, 5, and so on. And if I turn it left, and you see it decreases. 2, 1, 1, 2, 3, and if I click it, well, the decimal point lights up. Click, and oh, come on. Oh, the debounce. Okay, listen. Yeah. Okay, that's it. Now, the code it produces. I show this here. I connected my scope on the 2 test points. And well, let's go up to say a large time scale, which say 1 second, and start running. Okay, now you see, and the first thing you notice is that the signal always changes. What I'm doing now is I'm turning the knob right only, right, always right, and I see in each step the signal changes. Now I'm turning it left, and now I'm turning it left and then right. So you see, there's no change because there's always a change in the signal. So the time base isn't good enough to see what is actually happened to interpret the code. So I'm going to a time scale of 250 microseconds. Yeah, this is a quarter of a millisecond. Come on. And I'm doing a single sequence, and I'm turning this thing right 1 time. Oh yeah, that's great. You see, that's the bouncing effect. That's a very good demonstration of what it does if it bounces. But I suppose, let's say, 250 microseconds is too much. I wanted 25 milliseconds, actually. That's what I wanted. Yeah, let's do it again. Single sequence, turning it right 1 time. And a second, yeah. So you see that the 2 signals do not change at the same time. There's a delay. The blue one changes first, from low to high, and then the yellow one. I'm doing it again. Well, after I did the change, of course, the signal both signals stays at high level. So I do another single sequence and turning it right 1 more time. Oh, come on. Okay, now you won't see anything. 1 more time. That's what we had. Sometimes it doesn't trigger. So what I want is, yeah, that's what I want. So from high, you see, there's a change, and this time the blue one falls first, and then falls the yellow one. So, and that's just this here. The red one is a yellow one on the scope, and the blue one is blue. I'm turning it right, then always the blue one will change first. You see? It's the first to rise, and it's the first to fall. And if I'm doing it the other way around, it will always be the red one who changes first. Rises first and falls first. Demonstrate. Single sequence. Now I'm turning it left. Oh, come on. Yeah. This is when we change from low to high. This is yeah, that's that one. As you can see, the yellow one changed first. Yeah, that's what happened. And we're doing it one more time. Left. Yeah. Now you see also the yellow one, which is that one on the picture, falls first, then the blue one. Yeah. Yeah, well, that's the code this encoder here produces, and the microcontroller's job is to decode this. I mean, can you? Oh, that's Colombo. That's not what we wanted to see. Yeah. Let's make it a little bigger. Not quite possible with that one. And that's the code. I mean, you won't be able to read it probably. That's the whole program I used. That's the routine to drive the 7-segment display. Yeah. There we go. So the gray code that comes in here is, well, the trick is that only one signal will change at a time. You see, not both signals change at the same time, and the direction can be derived from which signal actually changed first. That's what I showed you. Alright. One more point. This code corrects itself. This is a mechanical device, so it bounces. I already showed you what it looks like, but we can do this one more time because let's go to a smaller time base, say 500 microseconds, and do this again. Yeah. One more time. It already bounced, but no, this time you see this is a very nice change. It didn't bounce. But let's do this one more time. It didn't bounce. Let's do it one more time. Didn't bounce. That's great. Does only do that if it shouldn't. Yeah, now it bounced very heavily, as you can see. This is what happens if a mechanical contact closes. It will bounce a few times from low to high. Well, it even bounced. It bounced several times, and then it got stable. And the really beautiful thing about this gray code is that no matter if it bounces or not, it's always fine. So I would have to go into more detail about all this, but I think it gives you an impression about how those encoders work and how they can be put to use. Yeah, enough for now. Thanks for watching.